Make a quick video about a fun, or not fun, math problem relating to a project that my students do. So there's a game called Pentago. It's a great game. It's very simple rules. You try to get 5 in a row. When you put one marble down, you have to spin a piece. The other person goes here. They can spin any of the 4 pieces, and they can only spin them 90 degrees. And then we will go here, spin a piece, and you guys will see. It's actually really hard to play while watching the camera. Here, we'll spin this piece. This person will go here, and we'll spin this piece. This person will go here, and I'll spin this piece. Oh, we'll go ahead and just replace that guy, and they'll go here, then this person will go here, spin it that way, get 5 in a row. Okay, so my kids make this game, and here's an example of it. I want to show you a problem that they've run into. In this game, you can also go diagonal, so you can go vertical, horizontal, or diagonal. But there's something that happens when you go across 3 pieces. So right here, it lines up near perfectly. Actually, I think this isn't exactly right. They might not have, appears to be maybe slightly off. So they might have got their math wrong, or it might have just been some tolerance issue. But you can see here, for the most part, that's pretty straight across those 3 blocks. I want to show you this problem with one my student built. If you watch when they go diagonal across, this line goes up and then back down, and the corner dot is not connected. Well, we went about trying to figure out how to solve this problem. I wanted to challenge anyone who likes math or is interested in solving this problem how to do it. So you'll see that when they build this game, they get to choose the size of their pieces, so they can have bigger blocks like this, or smaller blocks, or even smaller blocks than that. They also get to choose the width of their border. Now they use these borders right here. But there's some of them cut their own thin ones like this, some of them use thicker ones than this. It really just depends. So there is no set distance for them to know how far to space their dots. And so I wanted to figure out an algorithm to do that. And we have, it is possible and it is solvable, but it's definitely one you have to kind of think outside the box a little bit. So here's our problem right here. So I used the example of 2.5 inches. So I thought it worked real well. I think that's the size of the one I just showed you. But you can see the square length is 2.5 inches long. The border up here is 1/4 inch, just like that one I just showed you. And there's some other total distances there. But we're going to say one side of one of these squares is the width of the square. So we're going to call that S. And we're going to say the width of the border, which is 1/4 in this example, will be B. So that's the width of the border. And then we have D up here, which is the distance between the dots. Now there's 9 dots on each square, and the middle one needs to be in the middle point. I had drew these by hand, so it's not. So, and it's not the diagonal distance, because obviously that's going to be longer than the vertical or horizontal distance. So if you can look at this right here, here's the problem, and figure out how to line up so that little all 3 dots line up when we go across 3 pieces. That is the problem. Good luck.